So now, instead of graphing in standard form, where we're finding our intercepts, this is just the more common equation that you're probably really familiar with from last year. Slope-intercept form. Everybody's favorite, the y equals mx plus b. So we're still talking about a linear equation. The only difference here is m gives you your slope, and b gives you your y-intercept. And we remember from last time that our y-intercept is where we cross the y-axis. And your slope is how much your graph is changing, right? It's your rise over your run. Rise over run, so you're always going up or down, and then to the right. This is up, down, and then denominator tells you how many to go to the right. So when we graph these, you're going to look at the equation, you're going to pick out your y-intercept and plot your y-intercept. And then you're going to use your slope to tell you how many to go up or down and how many to move to the right from your y-intercept. So the first thing you're going to do is plot your y-intercept. And then you're going to rise and run from the y-intercept. Familiar? Yeah. Right? This is like everybody's favorite vector folder. They teach it to you over and over and over and over again. Your dreams of y equals mx plus b. All right, so if we look at the first two, I graphed the first two for you, and this is what your stickies are for, so that you can make pretty graphs in your notebook too. So the first one wants to know what the slope, or describe the slope of the line. So when I look at that line, I notice right away they gave me points on my line. They gave me 0, 0. Then they gave me 1, 2, 3. They gave me 3, 2. And they also gave me -3, -2. So if I'm going to describe my slope, I just want to look at 2 points. And I can pick any 2 points on my graph. I want to pick points that fall on nice whole numbers. I don't want to pick something like this, because what the heck, then I have to try and estimate those decimals. And I'm probably not going to estimate them very accurately. So I want to make sure that anytime I'm picking a point, it's one of these points that are right on intersections on the coordinate grid, that have whole number coordinates, because that makes it easier for me, makes my answer more accurate. So I can pick any 2 points. I always like to pick 0, 0 if it exists, because it's easy to work with 0. And then I just want to know my rise over my run. So when I look, I'm going to say, okay, if I'm starting at 0, 0, I want to know my rise is how many I have to go up. So since I traveled up 1, 2, my rise is 2, and my run is how many I have to go over to get to that point. So I went over 1, 2, 3. So my run is 3, which means my slope is 2 over 3. So for the first time in our entire lives, fractions actually make it easier, because fractions tell us how many to go up and down and how many to go to the right. If I gave you the second one and asked you to describe the slope, what do you notice that's different about the second line? It's going down, right? It's like going in the opposite direction as the first slope. This first graph, like if I was climbing it like a mountain, I was traveling along it, I'm getting higher and higher and higher, I'm going up, right? But this one, now I'm coming down. So because that graph is facing down, that tells me right off the bat that my slope has to be negative. And I'll see that again because when I pick my 2 points, I want to see my rise, and I have to go down in order to get to my second point, and then I can go to the right. So because I'm going down, my rise there is 1, 2, 3, -4. And my run is 1, 2, 3. So a negative is just going to tell me to travel down from my y-intercept instead of traveling up. My run, I'm always going to move to the right, whatever my run is. So I can also ask you to describe the slope, and I can just give you a table, which you saw. We've seen lots of tables so far. But if I ask you to find the slope and I give you an XY table, I'm giving you a bunch of X values, like 4, 7, 10, 13, and I'm giving you the Y values that coordinate with them, 20, 14, 8, and 2. Anytime we're talking about slope, whether I'm giving you a graph or I'm giving you a table, you only need 2 points. So you can pick any 2 points that you want on there, and then we're going to use those 2 points to decide what the slope is. two favorite points that you like up there the best? 4 and 20. All right, beautiful. 4 and 20. What else? 10 and 8. All right. Little sad there's no zeros, right? Zeros are easier. Do you remember the equation for finding slope? So y equals mx plus b is our equation for the whole line. We want the equation that's just for the m. Always the tricky one that everyone forgets. So if I want to find my slope, I want to do my x1 minus, line 2, you want to do y1 minus y2 over x1 minus x2. Is that coming back to you? Okay. And remember, so my x and y1 are going to come from my blue point, and my y2 and my x2 are going to come from my yellow point. And all I'm going to do here is plug in and then subtract. So instead of writing y1, I'm going to look at my blue point and say, okay, my y value of my blue point is 20. So I have 20 minus y2, my y value of my yellow point is 8. Over my blue point's x value is 4 minus my yellow point's x value, 10. It's coming back to you? Yeah. So now, I am still okay if I had picked to use the yellow point first. That's okay. I just always need to make sure that I line up my y and my x value. They have to be the same. So whichever point I pick to use first, whatever y value I use first, that x value has to come first. Does that make sense? Okay. So you can switch them and still get the same answer because you can pick either any of those points, but you just have to make sure that whichever y value you use, its x value is directly below it. So now, all I'm going to do is subtract, and I'm going to do 20 minus. So I need what? The y's are on the top.
Oh, they are.
We want to make sure, because our y's are our rise, how much we're going up and down, right? And our x's are our side to side. So now I just want to do 20 minus 8. 12, right? Over 4 minus 10 gives me negative 6. And then I can do 12 divided by negative 6 and get negative 2. So my slope there is negative 2.
I really thought you wrote that on the board.
So the difference there, though, is I don't have a denominator anymore in my slope, right? It's not a fraction anymore. So when I see numbers, whole numbers as slope, do you remember what I use for my run? 1, yeah. So anytime I have just a whole number, my run is always going to be 1. So I'll move up or down. In this situation, I'd be moving down 2, and then I'd go to the right 1. All right, here's our actual graphs. You ready? Last 2 examples. We're going to find the slope, we're going to find the y-intercept, and then we're going to graph the line. Because we talked about last time we just need 2 points and we can draw a line. So if I give you y equals negative 1/2 x plus 4, my m is the coefficient in front of my x. And my b is the number I'm adding or subtracting, the constant at the end, the one that doesn't have a variable next to it. And remember, my m is my slope. So in this situation, my slope is negative 1/2. And my b is my intercept, my y-intercept. And in this situation, my y-intercept is 4. So now I'm going to put in my sticky. So that we can graph it. I'm going to draw my x-axis and my y-axis. And the first thing I want to do is plot my y-intercept. So I'm going to go to my y-axis and I'm going to find 4 on my y-axis and put a point there. My y-intercept is 4. So I go 1, 2, 3, 4. And I'm going to plot that point. And then I'm going to use my slope to tell me how many to move up and down and how many to move to the right. So since my slope is negative 1/2, I'm going to go down 1 and over 2. So I start, and I do that right from my y-intercept. So I go down 1, which brings me here, over 2, which brings me there. And once I have 2 points on that line, I can draw that line through there. I don't need any more points. If you want to be super accurate, you're more than welcome to continue counting down 1 and over 2 and get yourself a couple extra points so that you can really easily connect the dots. If I wanted to move backwards, I would go up 1 and back 2. That way I can connect the dots and really see where my line is going. Also might help you more accurately catch some animals on your classwork. More points, because more points will make you more accurate. Do you think you could do the second one on your own? Why don't you give the second one a try? Pick out your slope. Pick out your y-intercept. Draw yourself a graph.